Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about how you can prove that variance x, where x has a gamma distribution, is given by alpha times beta squared. And here alpha is the shape parameter and beta here is the scale parameter. And in order to prove this, you need to apply integration by parts when solving some of the integrals. Okay. Now we're going to start off with perhaps writing down what is the probability density function. Well, probability density function when x is gamma distribution, when x has a gamma distribution, is given by this one. Okay, so here we have beta alpha, gamma alpha, x alpha minus 1 e negative x over beta. And if you keep on doing it again and again, somehow this long probability density function will kind of get stuck into your head and you'll be able to do this without really thinking too much about it. Yeah, so that's the probability density function. And we know that if we integrate this function from its lower limit to upper limit, the result here is going to be equal to 1. So that is another result that you're going to keep on using. Later on, you will see that we need to apply that result. Okay, so now let's move on to finding what is variance of x. Well, variance of x is given by this formula here. And we already have obtained this result. So in the previous video, I have shown that expected value of x, where x has a gamma distribution, is equal to alpha beta. So we're just going to use that result. Okay, so expected value of x here is alpha beta. Now what we need to do is we just need to focus on finding what is this value. Okay, so that's our starting point. Expected value of x squared is going to be, we have to apply the integration process. So here we have x squared and then fx is the whole thing here. Just going to write down the function. Okay, and it is going to be, we're going to consider the limit from 0 to infinity. Next, we can see that this part here is a constant, so we can take it out from the process and we can combine these two x's together. All right, so that's our next step. 1 beta alpha, gamma alpha, and then we have, if you combine these two x's together, the result is going to be x alpha plus 1. And then here we have e negative x over beta dx. Now for this part here, we need to solve it using integration by parts. Okay, and for that purpose, we need to let u equals to this part. U is x alpha plus 1. Therefore, du dx is going to be, well, you take the exponent you brought forward, and then if you, the exponent here is going to be reduced by 1, so it's going to be equal to x alpha. Okay. Next, we are going to consider this part here. We're going to call it dv. So dv is equal to e negative x over beta dx. And if you take the integral, you consider integral for both sides of the equation, then the result here is going to be v must be equal to e negative x over beta. The constant for x here is negative 1 over beta, and that's what we're going to put at the bottom part here. So that's the result for v, and we need to apply the formula for integration by parts, which is vu and then v du. Okay, so that's the formula which we're going to apply straight away at this part here. So we have 1 beta alpha gamma alpha, and for that part here we're going to focus on what is v. V is the whole thing here, which can also be written as negative beta e negative x over beta. So this one here can be written in this manner. And what is u? U is this guy, x alpha plus 1, and the limit for this is from we have here infinity and 0. Next we're going to minus v du. So v is this guy, which can be written as negative beta e negative x over beta. That is v. And then du is this thing with dx. So we have alpha plus 1 x alpha dx. Okay, so that's the process related to this one here. Okay, so what else can we do? We can simplify the process. Now let me just explain what's going on here. Well, okay, let me just write down the process. Maybe it's easier. So we have 1 beta alpha gamma alpha, and for that part here, we can write down this guy here in terms of negative beta x alpha plus 1 over ex over beta. The limits to be evaluated is from 0 to infinity. Maybe it's confusing using this notation. Let me just write straight. I'm just going to use this. So it's going to be evaluated from infinity to 0. I just don't want it to be confused with this guy and this guy right here. So I'm just going to use this notation. Okay, doesn't matter. Next, negative is positive. And of course, hang on, we can see that beta and alpha plus 1 are constants that don't depend on x. So we can put it outside of the process. So I'm going to write down beta alpha plus 1. Beta alpha plus 1. And next we're going to have infinity 0. And I'm just rearranging the position of x and e. So here I have x alpha times with e negative x over beta dx. Okay, so that's this part. Still this part. Now, you can see that if you substitute infinity into x at this position and this position, comparatively speaking, the value at the bottom here is going to get very large very soon. Therefore, if you have a small number at the top divided with such a large number at the bottom, the result is going to be 0. Next, if you substitute 0 into this, the top part here is going to be 0. If you substitute 0 into this, it becomes e to the power of 0, which is equal to 1. So 0 over 1 is 0. So in other words, this part here will be cancelled out. We get 0, really. Okay. Next, what we're going to do is, well, I can write down what happens then, final result for that. So now I'm just going to write down the whole thing. So simplify the whole look. So we have 1 beta alpha gamma alpha, and that will be multiplied with this part here becomes 0. So what we are left is beta alpha plus 1, yeah, and then it's going to be multiplied with infinity 0 x alpha e negative x over beta dx. Okay, so that is what we have so far. Next, what we can do is, you can see that we need to do one more time applying integration by parts to solve this one here. Okay, so that's what we're going to do next. I'm just going to continue the process. So what happened is that here we have hang on, this one is equal to 1 beta alpha gamma alpha. Oh, hang on, I can write this one here on top of this guy. Okay, so here we have beta alpha plus 1. Yes, so beta alpha plus 1 times with 1 over beta alpha gamma alpha. And next, this is what we're going to integrate. Let me just write down the function first. We have 0 infinity x alpha e negative x over beta dx. Yeah, that's what we have. Okay, now what we're going to do is we are going to focus on this part, how to get this result here. And again, we're going to apply integration by parts by letting u equals to x alpha. Therefore, du dx is just alpha x alpha minus 1. Next, we can say dv is negative x over beta dx. So this is dv and this is u. If you apply integral for both sides of the equation, then the result is going to be v must be e negative x over beta, and the constant for x here is negative 1 over beta, so that's what we put right here at the bottom, negative 1 over beta. And this can also be written as negative beta e negative x over beta, right? Okay, so this is what we're going to consider. And of course, the formula to apply that integration by parts is given by vu v du. Okay, now let's just do that. So here we have beta alpha plus 1, beta alpha gamma alpha, and the blue part here is going to be, well, first of all, v is this guy, so write down v negative beta b negative x over beta, and u is x alpha, and it's going to be evaluated from 0 to infinity. Now minus integral of v du, so minus v is this guy, negative beta e negative x over beta, du is this one with dx, so here we have alpha x alpha minus 1 dx. Okay, right, so we're doing this blue part here. Now let's simplify what's going on in this blue brackets. Yeah, here we have beta alpha plus 1, beta alpha gamma alpha. Now what's going on inside here is that, well, this part here can be written as negative beta x alpha e x over beta will be evaluated from 0 to infinity. Negative negative is positive. Beta and alpha are constant, which you can take it up from this integral process. So we have alpha and beta. And then I'm just going to rearrange the position of x and e. So here we've got x alpha minus 1 multiplied with e negative x over beta dx. This is from 0 to infinity. Okay, right. Now, following the similar argument, you will see that if you substitute infinity into this part here, it's going to be 0. And if you substitute 0 into this part here, it is also going to be 0. So this term here is going to, we will be able to get rid of this term. Now, what is left is, now I can write the whole thing quite nicely now. So we have beta alpha plus 1, beta alpha gamma alpha. We're going to multiply that with alpha beta, and here we have infinity 0 x alpha minus 1, and this guy right here. Okay, Now, I hope you can see that I can consider taking this part here inside this integral process. Okay, so that's what I'm going to do. This is from 0 to infinity. So what we have here is now alpha beta, I'm going to multiply that with beta. So here we have alpha beta squared, alpha plus 1. And then this guy here will be taken back inside this process, this integral process. So I have 0 infinity 1 over beta alpha gamma alpha. Okay, so this is what we have. And I hope you can recognize that this part here is the probability density for gamma distribution. So this is the probability density for gamma distribution. And what we have is we have this probability density. We are having this integral of this function here. We're going to integrate this function from 0 to infinity, from the lower limit to the upper limit. And we know that the result of this is going to be equal to 1. So now we have alpha, I'm just going to expand this thing. So we have alpha squared beta squared plus alpha beta squared. Okay, so that is the result for expected value of x squared. Now, we are not done yet because we need to find what is variance of x. So therefore, variance of x is, we're going to take this value. This is expected value of x squared. So here we have alpha squared beta squared plus alpha beta squared, and we're going to minus this guy and you square it. Yeah, so we're going to minus alpha beta and you square it. So we have this guy minus alpha squared beta squared, and you can cancel that out. So the final result is alpha beta squared, which is what you are supposed to demonstrate right here. Okay, well, I think that's all for now. Thank you very much for watching.